the High Voltage Live podcast. I'm Willie Snyder with Nat King Code, coming to you live from the Mile High City. I'm joined by my awesome partner in crime, Mr. James Stalcutt, Volt Online Academy. He is the creator of this podcast, and dude, I'm telling you, you're bringing it every week, man. It's freaking awesome. I want to give a special thanks to NEC for Dummies. We're at 22.5, I believe now, 22.6, somewhere in there.
22.7.
Really? Okay, yeah, it's going faster than I can count. But it's really awesome. We appreciate all the people that participated in Nat King Code Myth of the Week. We had a really awesome myth this week, and it was a lot of fun. And I appreciate all the people from NEC Live. It's been really awesome sharing your content on our NEC for Dummies group, and just kind of being kind of helping hand getting you guys in here. I noticed we got people joining already, and this is awesome to be doing this and to be just tying this in with our group. If you guys have any ideas for any of our content or anything that you want to see us do or anything, feel free to hit us up, and we'll try to see if we can work it in. James has pretty much slides on everything in his program, and that's what's so awesome is I'm like, hey, I'm thinking about doing this, and I didn't even tell him this week. I just went and did it, and he's like, oh, I got a slide on that. So I thought it was pretty awesome, and it's just the sky's the limit when it comes to the Stalcutt design book, and really appreciate Senior helping us out, and it's awesome to have the knowledge like his in the
Oh, hell yeah, dude. Yeah, we just finished all the new updates for the journeyman publication and masters, and I'm going back now. I'm gonna get that all ready for putting the new stuff in for the 2020 and the code change books in the final stages right now. And well, I can't say anything right this second, but we hadn't signed the contracts yet. But I did have a meeting today on Zoom, and I'll just say there's some big things happening, and people are this company is huge. I'm just going to say it. And they've even taken notice of the illustrations and the online education we're providing, and they basically just told me it's the best they've ever seen, and said their own company can't even do what we're doing. So
nice. That's awesome. That's a good compliment.
Hell of a comment. I was like, oh man, thank you for that. I appreciate that, brother.
Yeah.
So
yeah, and I know you worked your tail off on the change book, and I can't wait to get my copy. You'll have to let us all know, and we'll drop links in our podcast so that you can get the newest edition code change book for 2023, and that's going to be awesome, man.
Well, there will be 238 changes. We ended up having to add one more because Leviton wanted it, and of course, as I said before, they have a pamphlet they come out with, and the Stalcutts are doing that pamphlet for them this time. That contract's already signed, and we just finished up sending over, unless they want some other changes, we just finished the safety manual for Amazon, and we did that one. We also did MD Anderson. So it just sort of shows the companies out there, they're putting trust in our ability, being on all these different standards and everything else committees, that we know what's going on and correlating it with the NEC and also the OSHA standards.
Nice.
Pretty good.
Yeah, so awesome. Welcome into the stream. And I apologize. Sometimes it only comes through as Facebook user, so sometimes I won't have your name in here. I think there's some kind of thing you have to do to get shown your name on the comments or something, but I don't know. We might end up switching streaming software at some point, but try to make it to where you can see everyone's comments better. This has been awesome, and I'll tell you what, I had so much participation this week. I was even reading comments on my way here, before I even put my headphones on, I was still reading comments. So it was really awesome. We had some really brilliant comments this week, and it was just amazing. I really appreciate everyone's participation.
Yeah, let's go ahead and cue it up. What do you say?
Roll it.
Myth of the week, baby.
It's time for Myth of the Week.
Oh, wow. Looks like we got Wika in the house.
Western
Awesome.
Electrical Contractors Association. Welcome, brother. I've been
Awesome.
out there quite a few times.
Yeah, so this week's Myth of the Week was pretty awesome. We had a little bit of an argument, a little bit of a scuffle that went on in one of the Facebook groups. And one of the guys was saying that stranded can, well, actually, I think he was saying solid can carry more ampacity than stranded. And so the myth I actually threw up here was if the actual National Electric Code treated them differently. And, there was kind of a interesting argument that we had. And per code, nothing really says anything, but we had a lot of really interesting comments about the skin effect and the electrons traveling on the outside of the conductor. And, due to that, they usually don't even use stranded or don't even use solid for anything larger than number 10. And that's actually in the code and stuff too. So, it was pretty awesome to bring this up and to, as you say, pulling through conduit. But, it's one of those things that I don't think you're really going to see any kind of skin effect when it comes into like these lower ampacities and the lower frequency a lot of guys mentioned. And so we had some really amazing comments on it. And I'm going to let James take over as far as kind of explaining a little bit more about how this kind of gets to be a myth and what the difference is between solid and stranded.
Yeah, what I did, I went and did a little research on it, but I automatically knew that based on code alone, the only time you're going to see a difference in the amperages is based on what type of installation it is. So if it's like in conduit, you look at table 310.16, and of course, if it's installed in free open air, then you're looking at 310.17, and you'll get different ampacities based on that.
Right.
But other than that, I didn't know anywhere in the code. So I started going back, doing a little research, and just to explain how is solid copper wire made. All right.
Okay.
And when they do this, what they do, they have these rods that are drawn that's using a series of smaller dies to reach the gauge that they need for whatever size we're going to gauge it at for that application. And then once they stretch that copper out, naturally it's going to get thinner and more brittle. In order to fix that brittleness that can happen when they stretch it out like that, what they do, they use a process that's called annealing. And when they do that annealing, what it is, they heat that wire up, and that makes it more stronger and more ductile. Okay.
Well,
and
I think they do a similar technique for copper clad aluminum as well.
Yeah. And matter of fact, when we did copper clad aluminum, I actually went and did research on that and had that information on there talking about how they anneal it and everything to make it stronger and more ductile. Okay.
Right. Okay.
And then when you get over here and you look at stranded, basically all this really is you've got a bunch of different cables or just a bunch of individual strands, basically a smaller gauge that are twisted together to cause a larger gauge conductor. And when they make this, basically the same thing is going to happen here is they'll take those individual wires, and when they're drawn and annealed together like that, then they'll run them through another machine that twists them, and then that's all around a center wire that they do that. And when they're looking at that, it depends on what type of gauge you're going to set that at. But once they do those strands there, when you have I think it was 7 or more, and 30 to 34 American wire gauge strands is how they set those, and those are added, and that's what helped makes those gains there to cause the conductor naturally to be what more flexible. And then if you look down there when they talk about those twisted wires there, for example, you'll see they talk about a class B and a class K, and when they get in there, they tell you how those are twisted, and you'll see one is tied concentrically, and then they add more layers, and the direction will be reversed at that point. And this just gives you a little bit of insight to how they go about doing these conductors, but it doesn't matter if they're individual or you're taking a bunch of individual wires, twisting them, they still will take and anneal that wire to make them durable and pliable. Okay. Now,
Okay.
the other thing, I started looking at this a little bit more, and I was like, okay, well, which one's better, baby? And
Right.
when I started looking at this, this was interesting because I'd done research on this, and I never really gave it any thought, to be honest. I
Right.
just never did. And so I put a little thing together here to talk about what is the most important part of this, and what it comes down to is which one is more flexible. That's going to be the crucial thing between the two, and how
Right.
long the run is, because depending on how long the run is, that's going to determine the strength, cost, and flexibility of that conductor and how it wants to be used. So
Right.
when you look at strength, naturally, if you have one strand, which is a solid conductor, naturally it's going to be stronger. It's going to be a stronger conductor. And the reason that is because that conductor is what? It's thicker, okay,
Right.
than a bunch of smaller ones that you twist together. And then you get to looking at the cost. This was interesting. I started reading this because solid copper is actually cheaper to produce because
Right.
it takes fewer steps to do it, basically, and you only have to have that conductor annealed once. Okay,
Right.
when you get into stranded, it's the same thing, but you're annealing all them conductors, and then you're twisting them together to form that finished conductor size. So that's naturally going to add more time and cost when they're doing the manufacturing process of that conductor. And then, of course, you get into flexibility. Okay.
Right.
And based on that, if you don't really need much flexibility, probably it's better to go solid. But you got to also, and I didn't put this right here, but when you start getting into that, flexibility is easier to work with when you're in tight spaces. So sometimes you need to look at the installation and how much space you need, and if you need more flexibility or not. Because you get something in there that's solid like that, real tight, and you're trying to wedge it in there, you could get to where you can, over time, especially if you have a lot of vibration there, it could pop that lug.
Right.
So those are
Yeah, I've seen some crazy stuff before, like when you get the solid conductors into like a motor application, it'll break those terminals right off in a short amount of time.
yeah. And I started checking, and the load capacity, even though when you do this and you get the same size conductor, you're getting the same gauge size basically. A
Right.
solid wire is going to have less surface area than a stranded or something that's twisted and bundled together. And since that's the case, it's going to give it a higher load capacity and less impedance.
Right.
Okay. So that means solid wire will also has what? A lower voltage drop over them long runs, but it will heat up faster than stranded cable.
Right.
Okay. So when I look at stranded, naturally stranded is going to have a higher surface area. And the reason that is because you have several different wires that are wounded up together and twisted to create that one conductor. And there's going to be a larger voltage drop over the longer runs. And a lot of people don't know that. And the reason that is it doesn't heat up quickly. And why is that? Because it has air gaps in it
Yes, sir.
from the twisting, and that allows the heat to dissipate within that conductor along the length of that wire. And so when you're looking at this, depending on voltage drop, you might want to consider this when
Yes,
you're
sir.
looking between a solid and a stranded type conductor. And then, of course, when you get to corrosion, they'll tell you here a solid wire naturally is going to withstand corrosion better than a stranded one. Okay. And we tell you to remember about those air gaps that I was talking about a while ago, that they make up for the flexibility and easy to bend that wire and everything, but it also gives you more opportunities for what? Corrosion. And being that the conductors are so tinned like that, that can take and impede that corrosion. Okay. So just based on this, depending on what you're doing, then you make a determination which one is better. So I'm saying if you have a long run voltage drop, you might want to go with a solid.
Right.
You know what I'm saying? And and I'll be honest, I really didn't know all this till I started researching it. And I was up late last night putting all this together, trying to come up with something to explain this for the audience so they had a good idea what's the difference between a solid and stranded wire conductor.
Yep.
And so when you're looking at this, if I guess to sum it up, if you need it because of ruggedness, then naturally you want to go with a solid cable. But if you want to look at that, what is another thing that a solid conductor works well in? It's solid conductors are really good for where? Outdoor situations where you have approved sunlight resistant insulation. And it's also good for what? Direct burial applications.
Okay. Yeah, and you know, there's times before with stranded where guys think it's tight in the lug and you just walk up there and shake it and tear it right out of the lug.
Sure.
So you know, I was an inspector for a while, and every time that's the one thing I would expect is that guys wouldn't really kind of work the conductor when they were tightening it to make sure all those strands got tightened. And you know, with a solid, you hit that torque and you're good.
Yeah, you know? I thought when you brought this up, I thought, you know, this would be a really damn good topic to discuss here, and I need to actually do some research on it, you know, just to sort of see what's there. So I put, when you're looking at this, there's really no competition. So when I'm looking at this, what do you want to do? So I put in here, I wrote this up myself. Cutting corners or using the wrong wire may be cheaper or faster at first, but those early mistakes have the potential to become major problems as the years wear on. And that's what I was talking about, giving an example, if you went with a solid. So when you're using, and you're going to decide which type you want to use for electrical wiring or cabling, you need to consider the environment, the need, and the overall project itself. And that, based on those three things there, then you make an assumption which type of conductor you actually want to use, a solid or stranded.
Yeah, we got a question came up. Does compact conductor act like solid? And
in a way they do, but you still have the gap in there. You still got an air gap regardless. It's just a compact conductor. It's still individual wires that are needed and then twisted around.
So I was going to ask you, like, there was people that mentioned DLO cable, and DLO fine strands. Is that even mentioned in? Do they have fine strand in the code?
I did not even look at that. I'd have to go do a little more research on that. I'll be honest. I don't want to give any false information here.
Oh yeah, I agree. I was just curious because I know DLO is not in the code.
I've never seen it, but I did not research any of that on documentation and stuff that I was searching for to come up with the presentation I did here. So I don't want to make a false statement.
10-4, I agree.
You know, one of the things I learned a long time ago, my dad told me when I was teaching a course, he said, if you don't know something, don't give a false answer. He said, go look for it and come back later and answer it. And I've had that happen to me 3 times when I was out teaching. I honestly didn't know, and I said, I'll have an answer for you. And I had 5 individuals I could call and get the answer when I was first starting out.
Oh, nice.
Yeah.
Yeah, and it was funny because there was a few of the code individuals that were like, yeah, James is right on that. Once you've been on the committees and been on all the panels and stuff, then you really learn who to call and stuff, especially when you're dealing with hazardous chemicals and stuff like that. Like you taught me a lot about that kind of stuff.
Yeah, it was interesting. I remember I was doing a class and I put together this thing showing how to mix chemicals, and you mix them, and it gets based on a group, and from that group you come in and make the determination for the class and division. Okay.
Right.
And I was showing that in class. My dad had never seen it. I actually got it from one of the chemical engineers showing me how to do that. He goes, hey, I want you to put that slide and give it to me to put in my presentation. He goes, I hadn't seen that before.
Nice.
And that's something, coming from somebody that has as much knowledge as dad does. And he wanted that slide for that.
Absolutely.
But
he's always trying to steal our sweet stuff.
Well, here's a good example, and I'm going to show this. Now, this is where you're in a raceway, a cable, or in the earth where it's directly buried. So let's say we're looking at a number 12 with 75 degrees C terminals, and you come across here, it tells you.
Welcome in, Joseph Dumpy.
Hey, Dumpy. You'll see it's 25 amps, right?
Yeah.
Now, if I come over here and I pick up and I'm looking at table 310.17, this is where you got single insulated conductors and free air. You come down and look what the amperage is, 35. Yeah. And that's what I'm saying. That's the only place in the code that I know you're going to get these different amperages based on that.
Right.
Okay. So with that said, I would say we got a busted myth that's taken place, and basically both conductors tops are treated the same in general ampacity, but you need to take and you need to look at the type of conductor and the installation and application, and from that point you make a decision on which one you want to use.
Yep, absolutely. I would agree that I would say that, like in certain cases, number 10 stranded will work better for you. And then we also had another show where we did the fork terminals, where you do the crimp fork terminals.
Oh,
there is a technique that you have that I've actually taught some of my apprentices, where you strip that insulation and you leave some of the jacket of the insulation on there, and then you wrap it so that it doesn't unwind on you. And that's how we do it out in the gas and oil when we are center stripping, like number 8 and stuff. We go to them the like Myers hub bonding style Myers hubs and stuff, and that stuff out there is crazy bonded.
I'll tell you what,
7 times.
I think that is a hell of a presentation, because there's some information there that I'm sure a lot of people watching didn't even know. And I know because I didn't know, and I actually showed the presentation Dad for we're doing it and showing. He goes, "That's some good information." He said, "We're going to put that in our design book."
Awesome.
So, anybody that's had our design book, we have a lot of design tips on the side that tell you to think about this. And that one on the voltage drop, he did not know that about the solid versus stranded, that it would pull more, on the solid. And he goes, "We're going to put that in our publication." So
awesome.
That's what's great about doing some of these things, because you find a little extra information here and there. And we've been adding this stuff for many, many years, little items like that, so people can pay attention when they're going through reading the different topics that are in our publications.
Well, and I'll sit there and ask people at work, like, hey, which one do you think draws more amps, or you could use, can hold more ampacity, and I'll ask them, and they're, oh yeah, it's stranded for sure, you know what I mean? And, and it's really funny because, in all actuality, the stranded does work better for a skin effect, because you look at, that's the only thing they use when they start getting the 1/0 or larger, like you don't get too much solid conductors that they use for like power distribution or anything like that, and it's really interesting, I think we're actually going to start running out of myths if we keep busting them like this, but.
Well, I hope everybody enjoyed that little presentation, because I spent a lot of time doing a lot of research on that. That wasn't an easy presentation.
And that's the thing with the code change book too, is it going to be fully illustrated?
Oh, hell yeah. All of our
Nice.
publications are fully illustrated.
Nice.
I, matter of fact, we're about to do the commercial, and I'm going to show you the new illustrations for the 2020 journeyman that we just completed. Matter
Nice.
of fact, let's go ahead and kick it off. Let's go
All
ahead and
right.
get the topic of the week going.
All right. Got a compliment up there for you right off the bat. I said, well done, sir.
Thank you, brother. Appreciate it. I appreciate any comments that come in. You know, that's why we do this, is to do it for the industry. All right, let's look at commercial calculations. I'm excited to show everybody all this. All right, I'm going to go ahead and move forward here. All right, now what we're going to get into, I just sort of put this in, and I'm going to tell you in the 2023, 220.12 is now going to be 220.42. That's going to happen in the 23. Okay. They've moved some stuff around, but you're still going to get the same information. It's just been moved around, and they changed a few values in the table itself. So when you get over here and you look at the table, you'll see some of this has been changed a little bit. And what they did, you're going to notice the volt amps per foot over here. These are way different. And this is all due to the energy code. Okay. And we had to do a lot of updates on the our 2020 publication when it got into these full calculations. And I want everybody to listen to what I'm about to say. Okay. Now, the way that reading this, the way we have come up to understand this now, we used to take in the 2020, we would take these known load values here, and the table you're looking at now is a 2020. I'm telling you, 2023, something different's going to take place. Now, what we did in the 2020, we would take whatever the square footage was, take that volt amps per square foot, we would get our VA rating, and then if it was continuous use, we would take it at 125%. Okay? And we did that based on 230.42A1. But now reading the way we understand, the way we're reading it, looking at the new table 220.42 and the 23, which we'll do another class on this when we get there. But what I'm understanding now from this, from the substantiations, the 125% is already taken care of in the table. So you won't put 125% on it if you're applying the table for one of these listed type occupancies. Now, if the occupancy is not listed in the table, then you got to do all the calculations individually for the lighting fixtures, which will show that. Okay.
Right. Okay. So that's for the 2023?
Yeah.
Okay.
That's a big change that people are going to have to be aware of, especially when you have some of these jurisdictions and you go do your testing and they start basing on 2023. You need to be aware of this. And I have a feeling we probably will be the only one even showing this in the code change book.
Well, you know, like me, like code's just a minimum. I usually go code times 4 anyway, so I'll be like doing like 250, 300% on all my stuff.
Make sure that sucker's large enough. But with that said, I want everybody to really pay attention to what I said, because 2023, you're going to see a lot of changes coming up, and it's changing some of the calculations, and you need to make sure that you get a publication that is highlighting, showing how to do this. If the other publications, if they didn't pay attention to what actually took place here in the table, they're going to have wrong calculations in their publication.
Right. Okay? And so is that due to energy management, or is
that's the way I understand it? Due to the energy management code, the 125% is already calculated into the VA per square foot.
Okay. Okay.
Now, I will say this, when you get in and you start doing show window lighting, you do track lighting, you do outdoor lighting, you do your sign lighting, that doesn't pertain to this table, and you're going to have to calculate those if they're at continuous duty at 125%. It's just the table when you have this VA per square foot, and I'm going to show all that here in just a second.
Right.
Okay?
And I think the show window needs some changes for the next cycle, just because there's times I've gone to like little Starbucks store that takes up a little corner, and it has two full boats going to show window lighting. So they have 6 circuits, 6 20-amp circuits for a little Starbucks, and they all have this one little open sign.
Sure they do.
And it's like, really, dude? You need all this?
Well, and I think all that's interesting because you really have to understand how to apply. In other words, I want people to think of it this way. When you get in and you start doing your full calculations here for a commercial building, you're going to do it in certain steps. You're going to have your lighting loads as your first. Then you got your different receptacle loads. Then you have your special appliance loads. Okay. And I'm going to get in and discuss about the special appliance loads. And then you get into your compressor load, and then you get into motor loads, and then you get into the largest between the heating and AC, and then the last one, of course, is the largest motor load. So there will be 7, but if I'm doing residential, you got 6.
Right.
Which
I like how you break it down in those steps too, because it makes it easy for guys. I've had apprentices like come up to me and like, dude, I've never heard it like that before, and I'm like, oh yeah, dude.
Go stock up, baby. You want to learn.
we call it easy math. Easy math.
And when you go in and you look at our design, journeyman, masters, we break everything down in that form so you understand how to do those calculations properly. Okay.
Right.
Now let's take a look here. Now this is showing a basic load. Now what I'm going to point out here, we're just doing a general load for the lighting right off. Now you're going to notice I'm not telling you anything here that it's located in any type of occupancy. Okay. Right. So if there's no occupancy, naturally I have to do what? Just calculate the load. Okay. Right. Now, one of the things we point out in the illustration, we show you general lighting load at the top of the illustration. We say 220.12 and table 220.12. That's where you'll go if it's a listed occupancy, but this is a starting point. So if I had 70 amps of incandescent lighting, you take it at 100% at non-continuous. I've got electric discharge lighting, 90 amps of that continuous. Naturally, 230.42A1 is going to tell you take it at 125% for the service, and that's basically going to give you 182.5 amps of calculated load. Right. Pretty simple. It's easy to follow at this point.
Yeah, right? I do like that illustration. That's pretty tight. My only problem would be I don't think that Conductors is listed to support that luminaire. That's what's doing.
Well, it's just a quick illustration.
Yeah, I know. I'm just kidding.
Some of this,
all those cluster balls and stuff.
Sometimes it's hard to get to show every little detail in it,
Right.
But we tried to get them as detailed as we can.
No, it's sweet, dude. I was just giving you a crap.
Okay. Now, I want you to look here. We got the same setup, but we're in a store. 6,000 square foot. Now, if I go back and you look at table 220.12, you could take this and do it at 3 VA. That's going to give you 18,000 VA. Pretty basic. It's a simple calculation. Then if I come over here to the next one, look at this. Now we're going to add recessed lighting, but notice right at the top left-hand side, we're saying this is an occupancy that's not listed where? And table 220.12.
Okay. Now we had a question come in, and I look forward to your public comment. No, I'm just kidding.
Why? Put that back up there so I can see what that said again. Why don't they call it general lighting and receptacle? Because this one you're doing commercial. What you're referring to is when you're doing residential. And when you go over there and look at 220.14J, it talks about the general lighting and receptacle load. Here, you won't do receptacle load because you can have a lot of receptacles in here in a commercial building, and some of those will be supplying individual loads even that they plug into, and they're calculated different.
Right.
Okay.
Yeah. 10-4. I agree.
Now, this particular one is recessed lighting. We added in here, and you'll see we got 10 units, 100 VA each. Electric discharge lighting, 16 units at 180 VA. Oh, okay, he understands it. Incandescent lighting, you got 12 units at 150 VA. So if I look at the electric discharge lighting, you got 16 units, 180 VA. That's 2,880 VA. Then you got 150 VA of incandescent lighting. There's 12 units. That'll give you 1,800 VA. And then I got 10 units at 100 VAH for the recessed luminaire. That'll give you 1,000 VA. Add that up. That gives you 5,680 VA. And we're just telling you here, this is continuous. If you look in the illustration at the top, we tell you everything's continuous operation. So therefore, I'll take it at 125%, and that'll give you 7,100 VA. And that's the VA you would apply if it was an unlisted occupancy for that lighting.
So then basically in 2023, it'll be 5660, and then
no, you would still put the 125% here. But if it's in the table, you don't put the 125% because they're saying it's already taken care of.
Oh, okay.
You see what I'm saying?
Okay. Yeah, all right.
And we got to go back and make some changes to our calculations and stuff, where we show all these different full calculations for restaurants, stores, warehouses, and things like that because of this particular change. Because we actually show doing the total VA and then putting 125% on it. You're not going to do that in the coming 2023 version.
Gotcha. Okay, cool. Wow, I didn't know that. Interesting.
Well, that's why I do this stuff. Keep everybody updated.
Awesome.
All right, now here's show window lighting, and they're going to tell you here when you've got show window lighting, you're going to do 200 volt amps per foot. That'll be included for the show window, and this is of course measured horizontally along its base. So if I look at the show window lighting here, look at that show window there. It's got all the Vote Online Academy and all the publications. That's a sweet looking illustration.
Yeah, you got them all lit up, and you got six 20 amp circuits firing them things up too.
That's right. Promote, baby. But based on 220.43A, we just looked at it, said we're going to take each linear foot. I've got 100 foot, and it says I was going to take that at 200 VA. And then we're telling you here, this is going to be continuous operation per Article 100 NEC. That means it's going to operate for 3 hours or more. So take the 100 foot times 200, that gives me 20,000. Take it at 125%, and voila, you got 25,000 VA for your show window. Pretty basic. All right.
And then you would just basically divide that by your voltage, and then that'll give you
the amperage.
How many breakers you need for that, right?
No, the voltage, you divide by your voltage, it's going to give you the amperage.
Right. But I'm saying to figure out how many 20 amp circuits you need for that.
You wouldn't do it that way. You would do after you get that. Yeah, after you do the amperage, then you divide into the amperage, and that'll tell you how many you have. But not based on the VA, you don't do that.
Right. Okay, I got you. Because the 120 volts would give you the total amperage, and then you could figure out how many 20 amp breakers you need, right?
Sure. They do the same thing when they're doing it just based on a breaker. How many outlets can be on a breaker? You do that same process. It's based on the amperage, not the VA.
Gotcha. Okay.
You remember we did a podcast and I showed how to do the numbers per circuit?
Oh, yeah. Okay. There you go.
Yeah. All right. Now, the next one is getting in the track lighting. And what they're going to tell you here is that you're going to add an additional 100 VA that's included for every 2 foot of the lighting tracker fraction thereof. Okay. So when I get over here and I look at this, you'll see we got 30 foot of track, And then we're going to tell you for every 150 VA, you do that for every 2 foot, right? So all you're going to do is take that 30 foot, divide it by 2, then multiply it by what? 150 VA. That's
Right.
it. So I got 30 foot of track divided by 2, that's 15. So 15 times 150 VA is going to give you 2,250 VA load for the lighting track.
Yeah, and this is another one I think probably needs change for the next cycle, just because now like tracks don't use incandescent luminaires anymore. They use LEDs, and LEDs just don't really draw as much. So I don't know that you really need this much calculation on your tracks. I did a bar and it was all 100% LED, and I was throwing amp clamps on everything, and it was funny. I think I put 35 track heads in. It was drawing 6 amps.
Okay. Well, I think that's something that would have to be put in there for the committee to look at and how they would go about figuring that. Right. Because I'm like you, it's not going to draw that much load, but for right now, that's why it's set up that way.
75 per foot. I don't know what that is. I guess you could do it that way.
He's saying 75 per foot. When you divide the 2 into the 30 for the LEDs.
Yeah, you can do it.
In other words, cutting it in half. I know what he's saying, but they would have to do some research on that because it could even go lower than that.
Yeah.
I mean, you could take it down to 50.
That's a good comment.
Yeah. But yeah, I know. Is that what you were asking? The guy that just quoted on that? I'll move forward, but I want to get his comment back to see if that's what he was referring to. I think that's what he was talking about. Now, this is low voltage lighting systems, and basically the same thing's going to happen here. You've got 40 amps here of at your oscillating transformer, and you'll notice to me, I love this new illustration because we actually come in and drew one of these oscillating transformers here, and then we showed the type of panel they would have set here for all the different zones and everything. And I can tell you, when you blow this up, it shows exactly what it says on that control panel. Right. And basically, if you have 40 amps here, it's continuous operation. What do you take it at?
125%.
125% gives you 50 amps. It's basic. And if you want to put it in VA, you multiply it by what? Your voltage. That's it. Okay. So, and actually in our full calculations, we'll show a calculation like this, and then we'll multiply it by the voltage to put everything in VA. So all of our full calculations are all done in VA. And then at the end, it's divided by the voltage to give you the amperage.
Right.
In other words, we like to refer to it, it's like easy math. Okay?
Okay.
Did we get a comment from him?
I haven't heard back yet.
Okay. No worries.
Yeah.
Okay, I'm just going to assume that's what he was talking about.
Yeah. No, I think it needs some change. I think we're going to be like the leaders in public inputs for 2026.
Oh, yeah.
We're going to blow them up.
Now, this is where we're getting in the calculated load, and it gets based on the
total amp rating. It says 150 per 2 foot or 75 per foot, which that's the way I took it. But that's the way I took it, which is it's fine. You could do it either way. But that is a good thing. Like, you could actually cut it in half in a public input and probably be fine with LEDs. Yeah,
the 75 per foot, I agree with that, but I'm just the way we put it in there is to line up with what the code's telling you to do. So that's why it's laid out in that manner.
Yeah, I agree. Now, good comment. I appreciate it.
Okay, now this is where you're looking at outside lighting, and it ties in with 220.8B. And basically, you look here, we got 50 units at 120 VA each, and this would be, say, parking lot lighting. And you take that 50 amps at 120 VA per unit or for each light pole, and that'll give you 6,000 VA. We're telling you that will burn for 3 hours or more. Of course, it's at night, so it would. And you take that at 125%, and it's going to give you 7,500 VA. Now, the one thing I'll point out, when you're going through all of this and we showed you the full calculation, it is stepped out like this. And we're right now, we're doing load. We're still in load number 1, which is dealing with the lighting loads. Now there's one more load that's left here. All right. The last load that you need to think about on your lighting is going to be your sign load. Okay. And when you come over here, they're going to tell you have to have at least 1,200 VA. Okay. When you're doing this calculation. And that ties in with 600.5A that says the outlet shall be supplied by a branch circuit rated at least 20 amps that supplies no other type of loads. Okay.
Right.
So when you come over here, you look at this, we're telling you the load's 1,200 VA. But if I had on there and say it was 800 VA, you would have to kick it up to 1,200 VA. If it was 1,500 VA, then naturally you would do 1,500 VA. So in this case, we got a continuous operated sign load at 1,200 VA. You take it at 125%, and that gives you 1,500 VA. Now, what I'll say at this point, this is easy math. If you know the steps and procedures and how to apply this and keep it in a systematic format, you're not going to have any problems doing these type of calculations.
Yeah, I agree. And one thing that I found interesting too, like go back to the slide you had before.
Okay.
So, what was that one. So this is interesting because now we're getting these pole heads that actually have motion sensors on them.
Yep.
And so to me, that would change this calculation.
Oh, sure it would, because then it's not continuous operation. It's not continuous.
Yeah. And so it was just something to point out that with a lot of these lighting engineers and stuff, like maybe we can go in and we can actually put some public inputs in to the NEC, and we could get these kind of changed a little bit to say if you throw in some exceptions because you're spending a little bit extra coin on these light poles to make them energy efficient, then there's no reason that you have to size your conductors all massive because you're spending it on the front end with say running like number 6 out to that, when if it was non-continuous you could probably get away with number 10. We ran into it on a job, and I did the calculation, and it was pretty interesting. It was 300 foot out there for 2 lights, for 2 light poles, and I think it was a minimum size of number 8 to do to keep it in 3% voltage drop.
Right, and that all falls back to that should be engineered if they're going to have motion sensors on it and it's not going to burn for 3 hours or more, that should go in as a non-continuous load from an engineering standpoint.
Yeah, I agree. Sorry to interrupt.
Oh, no, it doesn't bother me at all. Just for the illustration, though, we're just telling you it's continuous to, so to apply that 125%.
Yeah, and can you go back to what is that? What is that sign? Does that say on that sign that I'm going to get my extra code changes this cycle? All right, yeah. I think it does. All right, cool. I just wanted to make sure that's what it said. I couldn't read the fine print there.
That says Boat Online Academy, the best electrical online training available.
All right. I like it. Well, nobody's posted anything better, so I guess we're going to have to assume that.
I just tell people just look at the illustrations and see what we're doing. And if you agree, great. If you don't, that's cool too.
I really don't know if that pole base is correctly installed, but, we're going to have to just think that, it's okay.
All right. Now, the other thing that I'll tell you, you take our electric sign and outline lighting publication. We actually show you how to do the calculation to do the depth and the type of soil and everything, and calculate how much concrete needs to be in there, and based on the height of the sign and also based on the dimensions of the sign to determine how much wind speed load it'll withstand.
Nice. Oh, all right.
Yeah, that's pretty cool.
Yeah, I wanted to bring that up, but I mean,
All right.
I was trying to say it was a good illustration. So.
Now, so far, I've done our first loads, which was lighting loads. All right. What's my second load? Receptacle loads. Okay. So now we're going to go into receptacle loads. And basically, what they're going to tell you here is for each one of those receptacle outlets, they'll be calculated at not less than what? 180 VA. Okay. Yep. That's the calculation I'm going to show here. All right. So if you look here, I've got 40 receptacles. They're at 180 VA each. And we're going to do a continuous and a non-continuous calculation here, okay? Just to show you two different options. So if I was saying all these loads were continuous, or these receptacles, I'd take those 40 receptacle outlets there, take them at 180 VA times 125%, that'd give you 9,000 VA. If they were non-continuous, naturally I take them at 100%, and that would give you 7,200 VA. That's pretty basic.
Well, and just to let everyone know, we actually did a podcast. One of our myth of the weeks was on this one specifically, and because this gets misconstrued into residential, and residential you don't have to do the 180 VA, and in commercial you do. So that's where that myth kind of gets put in there. So
yeah, and I will tell you this. We do this through our publications, but like if you were in a bank or office building, they tell you to perform this calculation, but also 220.4K tells you to take the square footage of the building at 1 VA per square foot, and whichever one of those two produces a larger VA is the one that you have to use.
Nice. I like it.
Okay. Now, the next one that you're going to look at, and this was a good question a while ago because he was asking about the lighting and receptacle load being combined. This is why you don't do these things when it comes to commercial. When I'm doing receptacle loads, and if I get over 10,000, you take the first 10K VA of that at 100%. Anything over that, you're allowed to derate it at 50%. Okay. Right. And this is per table 220.44. So if I come over here and let's say I have 150 receptacles, and we'll just say they're non-continuous. They could be continuous, but for this illustration, we're doing non-continuous. You take that 150 times 180 VA, that's going to give you 27,000 VA, and you take the first 10,000 at 100%, which naturally is 10,000, and then the remainder is 17,000 VA. You're permitted to apply a derating factor of 50% on that, and that'll give you 8,500, which will total that out to 18,500 VA for that receptacle load.
Right.
Okay. Now, there's one more receptacle load here we're going to look at, and this is where we're going to get into fixed multi-outlet assemblies. Now, I did make a joke about this a while back. They need to call this fixed assembly since somebody's out there saying that everything at the end of the wiring method's an outlet anyway. I mean, you know. This is a good example of that. All right.
Now, we can't have one definition ruining the other definition.
True that. Now, you got to look at two different types here. They're either to be used simultaneously, or they're not going to be used simultaneously. Okay. Now, if they're unlikely to be used simultaneously, for each 5 foot or fraction thereof, that separate or continuous link shall be considered as one outlet of not less than 180 VA. And if it's used simultaneously, each 1 foot fraction or thereof shall be considered an outlet of not less than 180 VA. Okay.
Nice.
So when I look at this calculation here, we're going to show you two different ones. We've got a multi-outlet assembly here. We got 200 foot of it. Now, if it's simultaneously, you just take it at 180 VA, which is going to give you 36,000 VA. But if it's non-simultaneous, it's at each fraction thereof of 5 foot. So I'm going to divide the 5 into the 200 and then multiply that at 180 VA, and it's going to give you 7,200. So you need to know if I'm using it simultaneously or non-simultaneously.
Hey, so question for you.
Mm-hmm.
Is that 5 receptacle outlets or is that 1 receptacle outlet per code definition?
That's one.
1 receptacle outlet, okay.
Because it's part of the multi-outlet assembly. It's considered one assembly. It's not now if you have multiple assemblies, that's different.
Okay, gotcha. Yeah, I just thought that was interesting because that's a 2023 change, or is that a 2020 change?
I think it was 2020, if I'm not mistaken.
Okay. Yeah, it's interesting because a lot of guys think that that's 5 receptacles.
Well, it is 5 receptacles, but it's considered an assembly. It's not considered
So it's 1
individual.
receptacle outlet.
Yeah, it's 1 multi-outlet assembly. So if something is plugged in all the time, like a computer, is it continuous? Sure, it'd be continuous.
I would actually say no because it's not drawing full load.
It depends, because you have to look at that assembly and what's being pulled on that assembly. And if you're leaving something plugged in all the time, it's sort of like a house. When they do the general receptacle and lighting load for a house, they're under the assumption that not everything's going to be plugged in at the same time. And that's why you get that 3 VA per square foot and not calculating everything individually.
So that's one of the languages that a lot of people miss in there, that like if I plug my computer in and I just leave it plugged in, it's not going to be drawing its full potential. The only way it's going to be drawing full load is if I'm loading movies or watching a movie or doing something on it. Then it will be running at its full load. But if it's just plugged in and it's just sitting there, then it's not running. I would have to actually put an amp clamp on it to tell you yes or no. But the definition of continuous load says running for 3 hours or more at its peak running capacity. So if you have 3 computers running idle and they're not running at their full speed, that's not continuous load.
Yeah, and that's what they get into when you're looking at what it's pulling. That's what I'm saying. It, take like an office assembly they bring in, and they've got all them assemblies and everything put together with the plugs and all that. You got people in there working all day for 3 hours or more. That'd be a continuous load. And that's what I'm saying. It depends on how that assembly is being used, whether or not you're going to consider it a continuous load or not.
Yeah, because see, what I'm seeing on that multi-outlet assembly, you could plug in 5 heaters, and those 5 heaters are going to be working really hard at, like right by their feet. Mm-hmm. And then what ends up happening is it trips a breaker, and then we come in and they're like, yeah, we got all kinds of stuff going on, and then they hide the heaters, and then you're like, what? Why is it tripping the breaker? We're like, what's going on?
They know damn good and well why it is.
You go put an air clamp on, it's not drawing anything, and then once you leave, they go plug the heaters back in again.
That's why you're seeing now in those module systems that come out, they have different circuits in it now, and that's to take care of that, because they don't want them heaters on the same receptacle and everything that the computers are on.
Yeah, I might actually do a myth of the week on that. Are those dedicated neutrals in there?
Oh yeah, they do that, and they mark them too.
Nope. There might be some out there, but all the ones I wired, they're all shared neutrals.
The new ones that they got coming out, we had an illustration that we did that showed the different markings of the neutrals, and the neutrals were striped.
And see, that's cool if they're starting to do that now. The last 2 I did, they were shared neutrals.
I'd have to say, where did the assembly come from? China or something?
It was actually American Modular.
Oh, that's surprising,
but it was probably made in China. But I don't know. I'm just joking about that. But it was American Modular.
Okay, no worries. All right.
Yeah.
Now, that takes care of 2 loads. What's our third one? Special appliance.
Yeah.
So when you get into special appliance, all you're going to do is get whatever the amperage or VA is of that system, and being if it's continuous or non-continuous, you take it at 100% or 125%. Okay. So I did a good example here. This would be an appliance. This would be like where they had ovens or something like that. I mean, I could have used any appliance for this, but I thought that was a pretty cool illustration. And you've got an appliance load here, a 13,720 VA. If it's continuous, you take it at what? 125%, and that'll give you 17,160 VA. Now, if I have one that's non-continuous, I take it at what? 100%. And that naturally would be 13,728. That's how easy it is to follow along and do this. And that gives you your third load right there. Okay. Now,
and I don't know if I told you this. Willie Jackerson just hit 100th episode.
Yeah, baby.
So I was just like, when you were like 100%, I was like 100, 100, 100.
100, 100, 100. Give me 100, baby. That's all I ask for.
That's awesome, man.
All right. Now, that takes care of 3 loads. What's our next load?
Would it be, yep.
Compressor loads. All right. So when I get in and I'll start, oh, wait, I've got to finish this one. I forgot because we have kitchen equipment.
Okay.
If you have kitchen equipment here, if you have more than 6 pieces of equipment, like you're in a restaurant, then you can take that at 65%. If you had 5 pieces, you could take it at 70%, 4 pieces 80%, and 3 pieces 90%. Okay. The calculation I'm going to show here is where we have 6 or more. All right.
Okay.
Now, I'm going to tell you what, there was a lot of detail done in this illustration. This took hours and hours to draw all this stuff, but they literally come in and drew the boilers, the microwaves, the fryers, the steamers, the kettles, and drew the ovens.
I was thinking those are kegerators. You got me all excited. I was like, oh, dude, you got the kegerators in there. You should just edit that to kegerators. That's what they look like.
Kegerators. But, you know, I'll tell you, I've seen a lot. I've never seen this kind of detail in any of the publications out there. So what they did, we show you here with we're just giving you the information right now. We're telling you there's 82 kW of kitchen load. All right. Now, when you add all this up, we have 16 pieces of equipment. Of course, that exceeds the 6, and it said I can put a 65% demand load on that. So I'll take the 82 kW at 65%, and that's going to give you 53.3 kVA, and that's all based on that table 220.56.
Well, and that just goes to show why these big name people are reaching out to you and wanting to work with you. And to me, I'm real excited. I think it's awesome. I'm literally a nobody in code or anything. You know, I'm doing this for fun. I have a good time doing it. I started Nat King Code because I want apprentices to get licensed. I want everyone to be licensed. I want everyone to strive to be better in their career. And you know, that's the whole thing. If you guys if there's something you don't understand or something that's bothering you in school or something, like just go search the Nat King Code page on whatever's bothering you. And I almost guarantee we probably already covered it. But if we didn't, reach out to me. We'll cover it. We'll get you, trained up on whatever you need. And to me, it means a lot when my apprentice is like, dude, I learned like 10 things in one day. You know, to me, that's awesome. And that's my whole point. That's what I'm trying to do. So appreciate all the people in Nat King Code for giving me input and reaching out, let me know what they want to learn, what they want to know.
Hell yeah, that's what this is all about. And that's why we put the time in to have this type of podcast.
There's times where James is just sitting there blown away with some of the stuff I'm telling him from the field. And there's some of the stuff he's sitting there interpreting from the code that he's doing, and I'm like, whoa, I never heard it that way before, you know. So we're all learning at this point, and it's not anything that we're trying to have an ego over anybody. We're just trying to, you know, get a message out there and get learning every day as a thing, you know.
All right, so that took me to compressor load, right?
Yep.
Now when you come over, you're going to look at three sections. You're going to look at 220.14C, which is going to deal with the motor outlets, and it'll refer you to 430.22 for single motor, and 430.24 we have two or more motors, and then 440.6 where I deal with what? Compressors.
Yep.
And 220.50 does the exact same thing. It refers you over where you have the multiple motors, and you also include in that where you have the hermetic refrigerant motors. And if you remember, in 220.50 in the 2023 code, it's going to say motors and motor compressors. Remember?
Yeah.
That's
So
the
is that the one where it says you take the largest one at 125%, all others at 100%?
No, that's in 430.24. What that's doing, it's just telling you you have to recognize that that is also considered a motor load.
Okay. Gotcha.
That's what they did there. It's just more of a clarification because you have your hermetic refrigerant motor compressors also.
Yeah. Okay. Gotcha.
And then 430.34 is the combination loads here. And this is where they get in and they're talking about where you're dealing with the single motor compressor. And then you also have your required ampacity for that motor compressor load. All right.
Right.
Now, when you look at this, and we drew some, I thought this illustration was really cool because this shows you an industrial process where you have them compressors. And you'll notice we even show you where you have the valves and everything. You shut them off and all that.
Mm-hmm.
This is a major upgrade from our previous type illustration. And we're saying you got two compressors here. One's 35 amp and one is 45 amp. And when you do this, all you're going to do is take the 35 amp. It's a 480 volt three-phase industrial process. So I'm going to do 480 volts times 1.732, and that's going to give me 29,085 VA. And then for the 45 amp, you do the same thing. That'll give you 37,395. And then you take all that at 100%, and that's going to give you 66,480 VA. Now, before anybody asks, why didn't you put 125% on that? Because the reason we did, we're going to do the seventh load, and the seventh load is going to be the largest motor.
Okay, gotcha.
So everything I'm doing right up to this point is at 100% for motor loads till we get to the final load.
Okay.
All right? Now we got the compressors. What's my next load?
Largest motor.
Nope. Motor loads.
Okay.
So now I'm going to look at the motors, and you're going to see the exact same sections. Only difference here, instead of 440.34, we're going to 430.24 because I'm dealing with multiple motors here. Okay. Now, what I'm going to do here, and you're going to notice this, I'm going to show all the motors, and I'm going to take them at 100%. Okay. So I kept it simple. I've got a 10, 20, 25, and 30 horsepower motor. They're all three-phase, 460 volt design B. You go look at table 430.250, and it'll tell you a 10 horsepower is good for 14 amps, 20 horsepower for 27 amps, 25 horsepower for 34 amps, 30 horsepower for 40 amps. Take all those at 100%. That gives me a total of 115 amps. It's 480 volt three-phase, so I'll do it just like I did the compressor, and that'll give you a total VA of 95,565 VA. So you'll see from right here, I'm going to go back, everything was at what? 100%.
Yep.
Everything's what? 100%. Okay.
100.
That's right, till we get to the largest motor load. Now, based on that, what's my sixth load?
Largest motor.
Nope.
Ah, dang it.
The largest between your heating and AC load.
Okay.
The non-coincident load.
Non-coincidental. Okay.
And that's over in 220.60, and it tells you to take the largest between your heating and AC, and that'll be what you use. So here, I've got a 10 kW heating unit, and I've got an AC unit at 5.5. Well, that's simple. The largest load naturally is what? 10 kVA.
Yeah.
Okay. Then it brings us to the very final load, which is what?
largest motor.
Okay.
Dude, I was rolling the dice the whole time. And like, it was just like, snake eyes. Oh,
No ties, baby.
dude, that was such a good roll.
All right, now look at here. We go through, we show you 10, 20, 25 horsepower. Then we tell you the compressor load's 40 amps and you got a 30 horsepower motor load. Then you got 7 amps there for your AC load. You take and look at all those. We can tell you that if you go look at table 430.250, the 30 horsepower is the largest motor load. It's good for 40 amps. But based on this, the largest load was 45 amps, which was where? The compressor.
Yeah, and I like that because you don't have to backtrack if you do the calculation that way.
That's right.
Because then all your math's already done, and then you just have to do your largest motor, you're done.
That's right. So all you do is add that additional 25%. So you take 45 amps at 25%. That gives me 11.25 amps. Then you take the 480 volt 3-phase, which is rounded up to 831 volts, and that'll give you a largest motor load of 9,349 VA. So if you stay within those 7 steps, you do lighting, all your lighting loads, do receptacle loads, then special appliance load, then compressor load, then motor load, then your non-coincident load between the heating and AC. Then the last thing is just whatever is the largest motor load. That's your calculation for doing a full commercial calculation.
Dude, that's awesome, man.
Hell yeah.
I like
Those
it.
illustrations look awesome.
Yeah, and you're not overthinking it. That's what's awesome about it, because a lot of people overthink that. And to me, that means a lot that you're willing to come in here and do that and just show people, like, here's how you do it. Dude, I'll tell you a story. So I was in apprentice school. This is before I got my license. And we were big 4-wheelers. We'd always go up to the hills in 4-wheel. We'd get our trucks stuck on purpose, and then we'd like spend like
I used to do that on my Jeep.
And then we'd spend like our whole weekend like trying to get it, brought out or whatever. And so then, well, awesome. We really appreciate that. Give us thumbs up. So it was funny because I had to miss my apprentice. What they did was they put me in a special class for just to take my license, it was like an advanced class or whatever, like exam prep. It was exam prep through IEC. And, I was like, oh man, it's awesome, and I really wanted to pay attention to everything, but my truck was stuck. So I was like, I'm going to have to miss a class to go get my truck out, So I was like, oh, whatever. I played hooky for one class, went up there, got my truck out, whatever, got back. So I'm at class next week, and the instructor's like, all right, let's go to the next step of our calculation. And he goes, what do we got to do? And I'm on largest motor. And he's like, I'm glad somebody was paying attention last week. And I wasn't even in the class, you know what I mean? So that's my number one call out, my number one shout out that I say every time is largest motor. But it's really awesome. It's really awesome that like we're not above anybody when it comes to. That's why we're trying to bring you guys this content, because we're not above anybody. We're learning ourselves. Like, and it's so awesome. Like when Pops comes on, he's like, "You guys don't even know about this," and it's so funny. And then we have to kind of like dumb it down. For some of the other, boys out there in the social media, and say, hey, when senior tells you you're wrong, you're wrong. You know what I mean? Like, it's pretty simple, so.
It's just like he was doing and showing table 43050 or table 43250, and he was telling you the voltage ratings and based on those voltage ratings, what it was based on for what type of frame motor it was. And and people were going, I never heard that before.
Yeah.
I mean, engineers and everybody like, where the hell did you get that information?
Oh, dude, when he did 7 steps of motor design, I was just like a sponge, man. Just, whoa, holy crap, this is good stuff, So it's really awesome to have him on there. And he learned all that stuff from actually out there doing it. And I'm kind of learning that stuff too. Like, everyone's like, oh, you know what? If you do this, it's not going to work. And then I'm like, all right, let's go do it. Let's go blow it up. I mean, like,
Go learn it.
yeah, so it's a lot of fun, and I appreciate everyone from NEC for Dummies that's participated in my Nat King Code post. It's meant a lot to me to build Nat King Code organically. We just hit 50,000 this week. So, to me, that was awesome. I mean, on one post a week, when I started Nat King Code, I was doing 5 posts a week. And I was just posting like stuff that I'd find on the internet, wherever, whatever. Like what I was trying to do, because I always liked doing journeyman exam questions.
Oh, yeah.
So what I wanted to do was I wanted to get recycled journeyman exam questions, and I wanted to just post them, and then get discussion on them. And what I didn't expect was guys like Russ LeBlanc, like, hey, I wrote that public input, and then I'm like, oh wow, that's cool, And so I kind of got a little bit deeper in with the code guys and with all the people that are in with NFPA and stuff, and it was really cool. It was really awesome. But then what do you come up with when you start doing that? You come up with scrutiny. You come up with people like, you're wrong. That's wrong. And you shouldn't do that. You shouldn't say that. You shouldn't say, code making panel 2 is dumb, or, you know what I mean? Whatever. I mean, to me, I'm not saying anybody's dumb. I'm not saying anybody's stupid. To me, when you're pushing for a code change on something that happened, a tragic incident where a child was killed in 2006 on an AC unit, and you want to have that AC unit with GFCI protection, just simply put AC unit in 210.8D and say it's specific compliance. That's it. It's really simple. Like, to sit there and play these little games saying it's an outdoor outlet, and to me, it just, I don't know. I think it's garbage, to me personally. Like, you go look at 440.3, no mention of 210.8F. You go look at appliance. You go look anywhere in appliance. It doesn't say anything about HVAC requiring GFCI protection.
Got a feeling 2026 is going to be a fun cycle.
Yeah, dude. I'm just like, really? Like, and these guys they want to fight over it. It's like, dude, why don't you just admit, like, hey, that was probably a bad change. Let's work together as an industry and get it fixed, because you can't just sit there and go, everything that's installed outside of a dwelling unit requires GFCI protection. It's not going to work, man. I mean, you don't want your electric vehicle to trip the GFCI. Oh yeah, sorry, never mind. That's a different code. That's a different panel. We got to respect the other panels.
Except for when you're trying to push something. But I think that's good. That could lead us in the next segue for the 5 code changes and see if there's something else they want to argue about.
Yep. I'm sure we'll hear it.
All right, let's pop her up and see what we got this week, because I don't even remember now.
I like it.
All right, let's look and see what we got for this week for the code changes. The first one we have is 342.24A and B, and basically what they really did was they added and put it more into a list item. And the main change that took place here was clarifying the total degrees of bends. And they're going to tell you that 360 degrees is permitted to be used for your intermediate metal run conduit between your pull points. That's what they were trying to clarify, was between the pull points. And then you're going to notice we got
David Engelhardt just popped in. What's up, brother? Oh, dude, I'm so glad David's doing good, man.
Work with them down there, brother. I saw that uh, um, Mark Candel's posted and saying they needed electricians down there to help. Said they got full-time employment for the next year, trying to get it ready. And by looking at Fort Myers, I can tell you Fort Myers is not going to look the same when they rebuild it, because that thing, it was destroyed, man. I feel for the people in Florida. That was unbelievable. But
oh yeah, somebody else. Welcome in.
anyway, what I wanted to point out here also is that this same change took place in all of those articles right there that I have listed. I actually, the code making panel didn't tell you this. You have to go to each one. But when I saw what was taking place with this change, I went ahead and we did it right here to let you know to go look at all these other articles for the same change.
Okay.
And pick those sections up, and you'll see all of them are in the 0.24. And you've got all the different types for rigid, flexible, liquid tight, your PVC, your HDPE. All of that is set up there, and you can go look at those sections to pick that up.
Did I do that? No,
I'll tell you, I try to get everything in here I can think of when I'm doing this stuff. And, you know, a lot of people don't realize there's a lot of work goes into researching all that stuff.
Yeah, I was just kidding.
Now, this is dealing with PVC conduit, and it's in 350.10b, and this is where we're talking about the uses permitted, and they're saying that PVC is permitted to be encased in concrete now.
Oh, so 352.10.
Yeah, they're just clarifying that it is permitted to be encased in concrete.
Yeah, and it's funny because there was one of the YouTube people out there that were putting GRC encased in their pole bases, and I was like, that's a code violation. It's got to be protected from corrosion.
Right.
And if you have the PVC coated, then you don't need to worry about that.
Right. And I think it's a good change, but it was just something people need to be aware of. And then also they did here when we're dealing with PVC conduit, and this is where they're talking about protecting it from physical damage. And they're just clarifying once again that if it's subject to any type of physical damage, you're going to need type Schedule 80. And that includes not only the conduit, but it also includes the elbows and fittings for that conduit.
Oh yeah, I know Willie Jackerson taught me about this one. You can throw the Schedule 4090 on there and then Schedule 80 riser and get away with some stuff, but not anymore, Willie. Gotcha, brother.
Well, this is a full and that's actually a big change in a way, because it's clarifying some things that were being done. It's almost like a myth too.
Yeah, we did that one. I'm telling you, Willie's been getting away with it, man. But your goose is took because they're starting to mark those 90s now.
Yeah. Now this is where you're going to get in. We're talking Article 366 deals with auxiliary gutters, and this is dealing with the uses permitted. And they added a whole new subsection here. And what this is going to deal with, it's going to clarify the uses permitted for associated exception for auxiliary gutters where you're up to and over 30 foot. Okay. It doesn't change the existing requirements. The only thing this does is change the structure of the requirement and improving clarity. So when you look at this in like the exception, this is where you're getting in and where it's used in accordance for 620.35 where you're an elevator, and this is where they're extending it a greater distance than 30 foot beyond the equipment that it's going to supplement.
Okay.
Given this requirement here saying this is okay, but they had to clarify it because they've been doing this in installations and elevators for a while in this exception, and this is just to clarify that it's okay.
Okay. I got you.
And then the last one you're going to look at for tonight is 404.1. And when I'm dealing with 404, this is where it covers all your switches, switching devices, and any circuit breakers that are being used as switches. Of course, these are where they're rated 1,000 volts or below. And what they put in here is a new sentence to clarify that this particular article does not cover wireless control equipment.
Okay.
And what they're saying here is when you look at this section, this is where you have all your switching devices and everything. But that one new sentence is making clarification at this point that wires control equipment to where those circuit conductors are not connected to, because it is a wireless device. You see what I'm saying? So therefore, it wouldn't be considered a switching device per Article 404 because it is wireless.
Yeah, I got a funny story about this one. We were doing a workout facility, and I started noticing that all the rooms, they didn't draw switches.
Mm-hmm.
And I'm like, don't you want me to rough switches in? And they were like, no, we can put them in later. And I'm like, well, this is a brand new building. I mean, we should at least put some. I was like, we should, no, well, what they wanted, it was pretty funny. They wanted their lights to be controlled by the music. So they wanted to be able to have like this music playing, and then the lights just do their own thing. It was some kind of like smart control thing.
Smart
control. And then when they started looking into how much it was going to cost to do that, it was millions of dollars.
Mm-hmm.
You know, I mean, it was ridiculous. You know, I mean, they'd have to have like these AV companies come in and do all this crazy stuff with all these controller power packs and all this stuff. And I'm like, shouldn't I just rough switches in just in case you guys need them? And the architect's like, we can just do those later. And I'm like, we should rough them in. And you know, what if these guys don't even finish this project? They weren't gonna want switches in there. I mean, dude, these are like 30-foot high ceilings. You know what I mean? I'm like, you know, we got to stub out above ceiling height and everything. I was like, you got to put switches. I'm like trying to convince them to put switches in, you know. Right. And so I did finally convince them to rough in switches and everything. And it was a change order, and we got paid because we bid. We basically bid with no switches, and then we had to put switches in. And they were trying to do all this like low voltage switching, and like I was like, okay, you realize there's 12 locations, and I have a 6-pole relay panel. Like, I can't be. I was like, how many offices do you want me to turn off with one? They're like, what? None. You know what I mean? Like, you know what I mean? It's just, they had these like 6 or 7 shower areas, and they were all on this relay panel. And I'm like, okay, so like this is gonna be kind of stupid because somebody's gonna want to go take a shower. They turn the light on, and then they turn the light on for this shower over here, you know, and then, you know, somebody's gonna be like done with their shower. They're gonna turn off the light in that shower over there, you know. Like, you can't do it like this. And they're just like, what, you have a problem with that? I was like, well, we should just turn them on like a time clock or something, you know, and then just they'll all be on for certain hours of operation or whatever. And they're like, oh, that's wasted electricity. I'm like, you know.
What they should have done was set it up for a low voltage system and 30 volts less, and they could have set up a zone areas through their control and all that with an isolation transformer to take care of that. That's what they should have done.
They tried that, but what they did was they sent it out to the supply house, and they're like, here, figure this out for us. And they're like, okay, a 6-channel, 24-volt relay panel. Okay, well, I got 6 channels. What do you want to come on the same everywhere? You know, because you have like 15 different loads that you want to control with 6 channels. You know, you can't do it. And you're right about the isolation transformer thing. Like, that is always a good idea. To me personally, it was kind of a cool thing that I learned, because it doesn't matter if it's 24 volt or 120 volt. You can't have a switch inside that shower area.
No. And that's what I'm saying. You set something up like that, like the one we showed just in the illustration, that was a 12 channel. And
Right.
I thought it was really cool the way they did it. But just little things like that and explaining how to calculate all that stuff, that'd have been the route to go, in my opinion. But what the hell?
Right.
All right, you
Yeah.
ready for tool of the week?
Let's
You
do
got
it.
your tool, brother. Here we go.
All right. Let's do it.
It's time for Tool Review of the Week. Sponsored by Electricians Only Tool Review and Nipex Tradesman.
And the
All
crowd
right.
goes wild.
This was a really awesome tool setup. I'm trying to switch off doing Milwaukee and DeWalt every week, just so I'm not like doing the same thing. Like I respect both tools. I respect Milwaukee and DeWalt. If you want the battery life to last, then you go with DeWalt. If you want the tool to last, then you go with Milwaukee, whatever. Milwaukee has some good stuff. I'm not going to knock them. This actual adapter thing, this is a little cutout tool where you can just cut out for your muttering of your box. And all you do is just put it on a multi-tool, you put it on the drywall, and bam, knock it out. So it's pretty sweet. I like it. My only downfall that I would say about it is it's too big for a cutout box. Like if you're doing a cut-in box and you do that, the box is just gonna fall in the wall. So I didn't like that. That was the one thing I didn't like about it. We were doing it in a situation where I could just, I was just testing it out, but we were in a situation where I could just tape it up, and because we're in a hospital, so we're doing these containment walls. So I just did it to check it out. It works pretty decent for a single gang muttering, but it doesn't work good for cut-in box. So maybe they have ones that are different attachments that you could buy that do like a cut-in box. It's a little bit smaller, and maybe they even have ones that have the little, tabs cut out to where the ears recess, because a lot of guys know if you don't get your ears recessed on a cut-in box, then it won't sit flush. But like I say, overall, with a multi-tool and putting this attachment on there. Now, with the Milwaukee, they actually do make ones that actually fit the Milwaukee, and they do actually make ones that fit the DeWalt. So you're going to have to just look for that. All these multi-tool kits, they do come, like it doesn't show it in the thing, like they do come with a actual adapter piece that will make this fit. But I didn't like it because it had like an Allen wrench thing, and it comes loose. And I didn't like that because it's kind of wonky, and I'd rather get the one that actually, so what you do is it has a little lever on the back of that, and what that does is release the blade out there. And so then what you could do is if you have the right attachment, then you could just release the blade and then slide that attachment in, and it'll fit right in there. If you get it for Milwaukee or DeWalt or whatever the brand is. But overall, I really see this as a time saver for us, especially like I have to cut like 3,000 ceiling tiles. So, like it just saves so much time to not have to cut each individual hole. You just put this thing on there with the template and bam, knock them out. So it's a really good tool, and I recommend everyone to try to save time at work. Like if you save 10 minutes, then that's 5 hours a day, or whatever.
Sure.
Whatever. I usually work 12-hour days, so like whatever it is. Depends on how much time you want to save. If you're saving 10 minutes in a 12-hour shift, that comes out, or when you add it all up, all the different times that you save comes out to like you're saving an hour a day. That's big time. Even if you're saving a minute a day,
Sure.
or a minute an hour, you know what I mean, times 10 hours, you're saving 10 minutes a day. That's going to make us more productive and better electricians, and be have an easy day. I always say have an easy day.
Easy
why
day.
have a hard day? Yep. Tomorrow is Easy Day Friday.
Easy Day Friday. I'm ready for the football games to start. Hey, we got Texas OU weekend.
Don't even get me started, man. We lost to the Raiders, dude. I'm like, no.
How about them Cowboys? The Cowboys looking good, boy, with Rush back there. Looking good, baby. Looking good.
Yeah, I will back up the Cowboys before I back up the Broncos at this point, man. It was sad, man. And then the Raiders had who we call Coach McDoofus, who's Josh McDaniels. So it's like, oh man, McDaniels came in, came in and beat us, and Denver, we just haven't come out strong. Like we could be there, and we could get it together this year. Russell, he's kind of he's we're struggling right now, but the whole thing is, I think overall, we beat a couple teams this year, and we need to just. I don't even want to go look at the game, dude. I know it already started, but
maybe Jerry will trade Dak to y'all.
There you go.
Y'all got Dak. I like Rush. Rush is looking good. He's got control of that offense. He looks fantastic.
Right.
But that's what America teams does. It's next guy up, baby.
Well, I want to give a shout out to Ben before I go look at the score. Ben Hochkoller, man, freaking good luck for your Colts tonight, and I'm crossing my fingers. We might do something, but I don't know. I think we're in Indy too, so Thursday night prime time. We beat San Fran prime time, but
you're up. The second quarter's almost over, and Broncos are up 6-0.
All right. Well, I guess sometimes you can win games with field goals, I guess. So.
No, it was a touchdown and missed extra point.
Oh,
I don't know. I'm just playing with you.
I would have never guessed that, but I wasn't watching the game, but I'm going to go watch now. So.
Yep. I'm about to get off and watch too. All right. Well, everybody, y'all have a good weekend and a good rest of your week, and we'll be back here again next week with some cool topics and myths to discuss.
And remember, make every day an easy day.
That's right. Use easy math.
Easy math.
All right, everybody. Peace. See y'all next week. We're out of here.
Thanks for joining everyone tonight. Thanks for joining Dave Engelhard. Hope everything's great for your brother. Appreciate you joining. Thanks for joining Anything for Dummies. Check out the new OK Publication. Thanks to the 2023 Electrical Coach. Appreciate you guys. NEC Deathmatch, the #1 competition in code. Thanks to the Lady Apprentices. Appreciate you guys joining in. Subscribe and ring the bell and never miss another show. Thanks to Electrical Coach.